Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with James Cornell, Managing Director of Life Panels in Australia. Thanks for joining us, James.
Yeah, thank you. It's great to be here.
So let's talk big picture. Life Panels, your company, is trying to bring natural and sustainable building materials to Australia, in particular, wood fiber boards and wood fiber insulation.
Yeah,
And
that's
this
right.
is a company you have been working on for a long time. You're originally from the UK and you had this really interesting idea that you wanted to pursue and you moved to Australia. So give us a little bit more about your background and why you went down this path.
Yeah, it's a good question. So my background, I started as a carpenter, like a trainee when I was younger, working for a furniture manufacturer, getting used to timber, different types of timber, moving through into site construction, building recording studios, and then into house renovations, and then served my time as a carpenter apprentice, doing traditional cut roofs, house framing, all of the things that you would expect to see from a carpenter. And during that time, I did construction management as well, because I always knew that as I got older, when I saw the old guys on the tools with, dodgy hips and shoulders going, I thought, oh, I don't want to be in that position. So yeah, trained for management as well. And then, just quite quickly moved through to run projects and lead projects, and then establish my own company with a view to, after a lot of questions and a lot of research about the materials we were using, when you're a trainee, you're given the bag of fiberglass insulation and you're in a real small roof space and you're expected to crawl around in all this dirt and, masks, goggles, your goggles steam up, you can't see. So yeah, all that basically led me to question,
why are we
really
building so with toxic materials?
Yeah, and I've always had a questioning mind. So I would, whilst I do respect, order and chaos at the same time, I actually like to kind of sit in the middle and ask questions of why things are chaotic or why they are ordered, so that helps me to then, I suppose, work out a good balance of the positives and the negatives of both, so you can actually make some good informed choices. And that led me to really question what we did. So the construction company that I set up was with an aim to build healthier homes, more natural homes, non-toxic homes, using better materials. And that was just the start point, but eventually the science comes and you want to learn more. But yeah, background as a practical tradesperson and master builder, master carpenter.
That's pretty interesting, because you're not like a lot of other people that I talk to come from like a software background, from the tech field, and all. You have hands-on experience. You are driven by personal passion for building better, because you have dealt with all these toxic materials and toxic building products, and you've questioned why we're doing that. Why not choose something more natural like wood fiber insulation, something more sustainable and eco-friendly too? So why did you move to Australia?
So two reasons mainly. The main reason initially was, since being a little kid, I've had a real interest in Aboriginal culture. I'm fascinated by Indigenous cultures around the world, and just, I suppose, more that real connection with the land and the real connection with how you live in a place, how you're connected to a place, and I suppose the impacts that ultimately you have on a place. And so the built environment, from that point of view, was always interesting me, whether it be palm leaves laid over branches, or paper bark trees and used for blankets or ground coverings. So yeah, a real interest from that. So that was one of the reasons. And then the other reason was the friends and the kind of contacts that we'd had here always talked about Australian homes being terrible, too hot, too cold, And when we came over a few times to investigate emigrating here, it was evident that, yeah, everyone's got AC just cranking. And I'm sure that's similar to the States as well.
Yeah,
And I
especially
do
this
remember that
summer.
when I visited the States, I do remember that, like, constant aircon, and you just get used to that way of lifestyle. But yeah, it just felt like an opportunity to take really, to move here to learn and listen to Aboriginal culture, and whatever that means for us to be here, and then also to think about, is it possible to import wood fibre insulation? And the research that I did, no one was doing it at the time. And yeah, it was a good opportunity.
So a lot of our listeners, or people, if anyone's watching this on YouTube, they're probably from the States, and them and myself too. We were really curious about what construction is like in other countries, especially in Australia. So how is it different? What sort of materials do y'all use? What insulation materials do y'all use in Australia?
Yeah, the typical, there are specific pockets of different regions that use things like double brick, but on the whole, most of it is timber stick frame. It would be a 90 mil by 45 mil house frame typically, or steel. Steel's quite a common building material.
For residential construction?
Yeah.
Oh, wow.
Steel frames. I mean, the benefits of that are advertised as it's truly straight. You don't have to plane the frames and whatnot. But yeah, for the most part, it's generally timber frames, and then infilled with typically a fiberglass insulation. And there's various guises of that. I'm not familiar with the brands that would be in America, but specifically here, there's ones that are all just fiberglass based, and then variants of that. So they use recycled content, or they've removed quite a large portion of the fiberglass and replaced it with other minerals. And I'll say minerals in inverted brackets, not entirely sure what that is.
So since they're so poorly insulated, they're probably, all those homes in Australia are probably energy guzzlers, just like they are here in the States.
Yeah, correct. Yeah. So obviously, similar to the States, overheating is a massive issue. And the insulation that goes in is often installed poorly as well, because people just instantly assume, or they hear the word insulation and instantly think the fiberglass bats, whether it's pink, white, yellow, brown, and so that's insulation for people. Whereas actually, as you know, and your brilliant videos show, it's way more than that. But for the most part, people just stuff it in. There's big gaps, so it is quite inefficient in the way it's installed already. And then couple that with the poor detailing, and materials that don't actually really help. Yeah. Aircon is just on 24/7, and because it's so hot here as well, in particular where we live, a lot of people just keep the blinds closed, so they're actually blocking natural sunlight from getting in, and thinking that we're getting too hot. So let's block it out, put the aircon on, drop the temperature. But then, as you know, at night time, all of that nice warm air that you might have got in your building, even though it's cooled air, it will just escape through the poorly detailed windows and roofs, and yeah. So it has definitely been an impact.
So the wood fiber that your company is selling is both an infill to replace the bats that people currently use in Australia, but it's also continuous exterior insulation for the outside of homes.
Yeah, correct.
So is there a lot of education that goes on your part, like educating the industry on the need for continuous exterior insulation and the thermal bridging that goes on through people's studs? Because like you were talking about, people think that they just insulate these bays, it doesn't have to be properly insulated, and that's it, that's all they need to do. Air conditioning is going to fix the rest of it. But you have this big hurdle ahead of you of trying to change the mindset of the entire industry and of people living in these homes. And you have to tell them that it's not normal to have your air conditioning run the entire summer. It's not normal to be uncomfortable in summers. It's something that we have been programmed to think is normal. So we can actually use better materials to make our homes and make our lives more comfortable. Is that a big hurdle that you face?
Yeah, definitely. And humans we're all guilty of it, being essentially lazy. We like the easy option. So obviously the aircon, it's super easy. You just flick a button, on it comes, and that's it. So to move away from that mindset, which is very common, isn't it? Like, you get in a car, you turn a key, you get your phone, you make a call, like everything's so quick and immediate and easy. So that's the benefit of the modern world that we live in. But the downside is it makes us think that a home is similar. Whereas for me, if we actually look at the fabric of the home, the building envelope, that's what we need to kind of address to make sure that we don't really need to rely on the mechanical air cooling, per se. It is an important factor, obviously, but it's not necessarily black and white. And that's what I spend a lot of my time talking about. The familiarity people are used to in Australia is external insulation is typically being foam based. So, sticking foam on the outside, and our product is quite similar to it in terms of the thickness, and that notion of fixing it to the outside of the frame. But that's typically only done on the walls, not the roof. Whereas obviously for us, we introduce a whole roof system and a wall system. So people get that, but then it's the actual physics behind the external wall insulation and why you wouldn't want to use a foam or say a silver foil sarking that's trapping moisture. So you kind of got two prongs of attack, like to educate people around, hey, here's a slightly different product to what you've seen before, similar application. So yes, you can use it in your roof, on your ceiling. Yes, you can infill it. Yes, you can wrap it around the outside. But then you've also got the education. And this is the bit that I find the hardest, is to why the building physics and why the building science is more important to understand. And that's typical. And your video about the R value that I'm sure a lot of people have seen, absolutely brilliant, because it nails that understanding that it's not quite the full picture of effective insulation.
Thank you. I appreciate that. So let's dive a little bit deeper into life panels, the wood fiber panels that you all are selling. So they're composed of, as the name suggests, fibers of wood compressed together with a small amount of adhesives. They are non-toxic. They don't have give off any VOCs or anything. And they're very versatile too. Like you said, they can be used on the outside of walls. They can be used on roofs too. And you can have a more fibrous, softer version that can be used in bays, in stud bays.
Yeah.
And what are the other advantages of wood fiber panels?
Yeah, that's a great question that I feel like I've got fairly good at breaking it down. So the first one that I always say is that it saves you energy, unlike other insulation, and that's to do with how it's made and I suppose the scientific characteristics of the material. But it saves you energy, so it will delay the sun's heat and how long that heat takes to transfer through your roof or your wall. Then it's a great insulation.
So let's focus on that, the delay of heat. How is that different than EPS or the foil-faced insulation that you mentioned earlier?
So generally, I've highlighted generally there's 4 key criteria of an insulation. You've got the density, and the higher the density, the better. So typically, a synthetic fiberglass insulation or a polyester insulation would sit at maybe 10 or 20 kilograms per meter cubed, and the infill that goes into the bays or the stud spacings, that starts at 60 kilograms a meter cubed for wood fiber. And then the rigid panel that you've got there on your desk, that starts at between 140 kilograms to 180 kilograms of density. And I've got a whole chart that shows these, in a bar chart form, so it's actually easy to understand how different that is. And it's astronomical, the difference between a 10 kilogram and a 20 kilogram.
I have a question about that. When I install mineral wool insulation, one of the instructions by the manufacturers is not to overfill it and not to compress it, because that can reduce its a nominal or its effective R value. And that's because the mineral wool insulation acts as an insulator by trapping air in between the fibers. So when you talk about density, that means more mass in a given area. Does that equate to less trapped air?
It depends, and that's a great point to raise. So that does depend, actually. But because it's wood fiber, and that it's very, very low conductivity, like 0.036 watts per meter Kelvin, versus typically on the mineral wools, you're probably at 0.045. And I know that only sounds like a small difference, but that
it
does
adds up. Yeah.
Yeah, it does add up. Yeah.
So it's because the material itself is different. That's why we cannot use the same logic as we would with mineral wool insulation.
Yeah, and also you get when you're moving into the science of air is, as you know, highly conductive. So even though it's insulated and you've got more air pockets in the mineral, and obviously, like I say, not to compress it, so it reduces that. With wood fiber, because of the density of it being so dense, the low thermal conductivity, that will actually delay and works with the specific heat storage capacity of the material to delay the time lag. So in terms of a thermal resistance, they're all fairly good, and I am quite fair to say that that is a good trait of insulation. But then it's the other components too.
Yeah. So how is it better than foil-faced insulation for roofs?
Because foils are not vapor permeable, and that's one of the four. So the first one is the density. Second one is thermal conductivity. The third one would be specific heat storage capacity. So the ability of the material to absorb heat. And again, a wood fiber versus a foil or the foams, they've barely got any ability to do that. Just the makeup of it. And there's a whole heap of scientific formulation that you can use. And I do back this up with science, because somebody said to me recently, would you say that you're biased towards wood fiber? And I said, yes, I am biased towards wood fiber, but not because I don't like synthetics and I only like wood. I'm biased because I believe in the science and the facts, and the science and the facts prove and demonstrate that wood fiber is already, 100 steps ahead of the competition.
So why do you think sorry, continue your last point.
I was just going to say the last one, to answer your question about the foil face on the roof, is the vapor permeability of it. So the ability to allow moisture vapor to escape without getting trapped in the roof or the wall system. And here we've got a whole heap of issues with mold, bacteria, condensation, and ultimately dry rot, which I'm sure you've probably come across on a few projects.
So when you say here, you mean Australia or your home?
Everywhere, Australia, yeah. And you actually see it in the UK as well. That was a big
and that's because moisture just cannot escape. Oh, that's a good point, because during the pandemic, people are working from home. Kids are also studying from home. Someone else told me there's a massive buildup of moisture from cooking, from exhaling, from just being in our home 24 hours a day. Someone I spoke to started noticing moisture condensation on their walls inside their home, which they had never, ever experienced before, because they were just in their home for, 8 to 10 hours a day, which has completely changed after the pandemic. Yeah,
and that's right. So typically when people think, we just need to insulate, and this happened in the UK a number of years ago, a big drive. So suddenly loads of people think it's the next money-making scheme. So they pay some dollars to become either like an energy assessor or an insulation installer that's certified, that we've got the approvals. But again, because people have kind of made it black and white and failed to recognize what insulation is, why insulation's there, quite often what happened in the UK was they sealed up the windows with double glazing, blocked off all the air vents to prevent air leakage, insulate everywhere, and send the insulation, and took anywhere that air was getting in before. So essentially a leaky building has now been sealed, but not in the correct way, because there is a good way to seal a building.
And they didn't change the HVAC system, I'm guessing.
Yeah. So all the air is basically trapped in. There's no air change. There's moisture just gathers and gathers and gathers and can't get out. So then obviously it condensates on surfaces. It creates mold in the cavities, or the materials and the insulations hold on to moisture. And that's a big one that we see with fiberglass, that it will take over 2 weeks for a fiberglass bat to release moisture. And that's when you've got good airflow. So you imagine you're trapped in a wall with silver foils and non-vapor permeable materials, then it's just a recipe for disaster, really.
Wow. And the sad thing is that we don't monitor our indoor air quality levels. If every home had a CO2 monitor or pressure, like we were monitoring our vapor, our VOC levels, all that stuff, people would be much more aware of the air that they are inhaling all throughout the day. But they don't. It's only when we see rot or something visible, then we realize there's a huge problem. But by then, it's too far gone.
Yeah.
That's
right.
dangerous.
Too late.
What do you think about spray foam insulation?
I'm not a fan. And again, only because vapor permeability, specific heat storage capacity, and then density, those four, again, it always comes back to these
those four. Even with open cell spray foam, which is vapor permeable?
On that, all I can say is, like, most of the questions, and like I said at the beginning, I like to ask questions, is let me see the data sheet. What's the vapor permeability of it? Does it meet the targets for vapor permeability?
Because every single mix is different. And every single application is different, as opposed to wood fiber, where it's a pre-manufactured product, you know what you're getting. With spray foam, there is so much manual intervention that goes on with the application. That's where it gets iffy.
Yeah. And if I saw a data sheet on that said highly vapor permeable, it's got good density, specific heat storage capacity is excellent, and then you plugged that into an analysis tool like Woofy, for example. I don't know if you're familiar with Woofy.
I'm not, no.
That's a German. You heard of Passive House?
I have, yeah.
So hopefully, if your listeners have heard of Passive House as well, it does connect to Passive House, but it's basically an analysis of moisture behaviour in a proposed wall structure or roof structure, and it highlights the risks of mold growth. It highlights the areas where moisture might get trapped, and things like that. So if by putting spray foam into the Woofy analysis tool, it said there's no issues, then I'd be kind of like, okay, no problem. But without that data, I'm skeptical of it because it's foam based. And so usually foam based materials aren't great.
I'm sorry. So when we were talking earlier about rot and mold with all these enclosed buildings with no air exchanges per hour, have you seen a big push in spray foam related to that problem? Does that make sense?
No, actually, that's interesting. We've seen in Australia in the last few months talk to move towards a higher star rating of energy performance. And that has led more towards talk of vapor permeable membranes, open cell insulations, taping of membranes, and then also things like heat recovery ventilation systems and mechanical ventilation. So the government-backed scheme does fall short of what I would consider to be, the base level of performance, but there is movement towards thinking about, okay, moisture is an issue here, mold is an issue here. But
they've identified that problem pretty early.
Yeah, and obviously there's so many experts in this field that it isn't black and white, because you have got mold. You've got people who assess air quality and mold particles in the air, and what's a typical level of mold that exists in all homes, and what's an acceptable level of bacteria. How clean should we make the place? So there's a lot of complex things to it. So I think for me, it's back to just a common sense approach, which is, do we want to get overheating in buildings? No. So we can use wood fiber for that. Do we want moisture to get trapped? No. Use vapor permeable materials. And do we want to be excessively cold? No. So therefore, good design, good junction, good insulation. that's good at locking in the heat. And again, wood fibre ticks the box. So to explain decrement delay with a little bit of a visual explanation, hopefully, if that even makes sense, usually I do a heat lamp experiment. So to mimic the sun's heat, it's an infrared heat lamp. And then I take 4 materials: tin, which would typically be on a roof in Australia, a polyester insulation that's got an R value of R2, a EPS foam that's also got an R2, and then a 60mm wood fibre panel like the one you've got on your desk there, and that has got an R value of R1.45. So it's slightly less than the polyester. That information is important. So what I do is I set them all up and I hit each one with the heat lamp for 5 minutes, and I use a digital laser thermometer to take the reading on the face and on the back. And it's only over 5 minutes, so I take the reading at the face, reading at the back. And what we see is after 5 minutes, the temperature on the back side of the tin has gone hotter than, increased more on the back than on the face, because the heat has transferred through the material. And because it's highly conductive, because it's tin, it's basically overheated within 5 minutes. So you imagine if that tin's on your roof, after 5 minutes of the sun being out in the morning, you're starting to overheat.
Wow.
The polyester insulation, after 5 minutes, has had a temperature change of around 12 degrees, I think it is, which is not too bad. It's quite good, but 12 degrees in 5 minutes is quite a lot.
Yeah.
So you imagine that equates to an hour. So after an hour, usually, and that's what we see, the polyester is incapable of preventing any more heat from getting through it. So it's already overheated on the inside as well after an hour. The EPS foam is pretty good. That's changes by about 3 to 5 degrees after 5 minutes. And so I always say, oh, that's good, isn't it? Because I do this live often in workshops, and people go, oh yeah, that is good, because they've seen the overheated tin, they've seen the increase on the polyester. And I go, well, it is good, but it's not vapor permeable. So that material is going to trap moisture. But then the wood fiber is at 0. So after 5 minutes, there's no change on the backside of the material.
Wow.
And so even after 1 hour, 2 hours, 3 hours, you wouldn't really see much change on the backside of the wood fiber. And so
that's the decrement delay that you're talking about.
That's the decrement delay, yeah. And that's what we say with overheating control. We want to maximize the time it takes, or prolong the time it takes for the sun to pass through the building envelope. And the best way to do that, and the most cost-effective way to do that, is with wood fibre insulation.
So how has the reception been to live panels in Australia? How many projects have you all installed this in?
Yeah, we're getting on to hundreds now. Been going for 4.5 years, nearly 5 years. And
mainly residential or commercial too?
Mostly residential. There's been 1 or 2 commercial, but yeah, mostly residential. And we offer the whole range. So you can just do the infill that goes in your bays or your stud spacings. So it doesn't have to be the whole complete system. But obviously the benefits of doing the whole system is good for your health ultimately. Yeah. But yeah, a few different options.
Right now you are importing this product from Europe. So is it cost competitive to mineral wool insulation that people are currently using in Australia?
No, it's not. And so on the chart that I told you about, the bar chart that shows the performance and why higher is better or lower is better, on that we've actually got a dollar value to performance value comparison, and the mineral wools are half the price of the wood fibre, and sometimes even greater than half the price, but the performance is on the lower levels, and the overheating happens within 1 to 2 hours, whereas just with the single 90mm wood fibre bat, it's more than double the price, but the performance is also more than double, and you get up to 4 hours of that decrement delay, the heat delay from the sun with one wood fibre.
So how
that's
do you...
kind of the education on it.
Yeah, but it does always come back down to price, right? We can
Yeah, it does,
spread
yeah.
education as much as we want to, but people are still working with restrictive budgets,
Mm,
homeowners, builders, everyone. So
yeah.
what's your eventual goal to bring down the price of wood fiber in Australia?
Yeah, okay. So that's two folds. Firstly, I would say what we do immediately now is we've developed a kind of cost comparison. So if you were to build this current standard off the shelf kind of home in Australia, that's obviously got a dollar value to it. Then we say if you want the full wood fiber system, it varies between kind of 6 to 8% more, and there's a dollar value to that. Then we say if you just do the roof, because you're going to get good performance from your roof, then it's maybe like 3 to 4% more. And then if you just did the infill only and just literally swap out the fiberglass or the mineral to the wood fiber, then it's about 1 to 2% more. So people have kind of got a, okay, well, we can't afford that, but yeah, we'll go with that. Or actually, 8%. And sometimes that 8% can be up at, $50,000, $60,000,
Yeah.
which is a lot of dollars, but people, because they can kind of see it, and we're trying to make it simple to fit in with that mindset of we just want to flick a button and cool the house. We're trying to tune into that a little bit.
Yeah.
But then for the future, that's where we are right now. But for the future, I've actually put together a whole complex plan to build a manufacturing plant in Australia to make the wood fiber, which would obviously drop the cost and make it more readily available.
That's exciting. So you would use local trees, locally sustainably and locally harvested lumber
Yeah,
in Australia to make this.
yeah,
Ha-
that's
Has
right.
it has it is it being done currently, or would you be the
No,
first?
this would be the first, yeah. So
Wow,
there's
that's
one or two
exciting.
people trying to, who's bringing in a few little bits. There's a few architects bringing in wood fiber on a sort of project by project basis. Because in Europe, there's 4 major competitors that are all, they're all really old, tried and tested. And that's the advantage for us as Life Panels, that the technology is not something that we've come up with in the last 10 years. This is, in some cases, 90 years old. So we've got that support and backing that this is tried and tested in all climate zones too.
That's very exciting. So I guess once you set up the facility and you're able to bring this price down, that would get over that hurdle and maybe it would be widely adopted.
Yeah,
Yeah, that's
yeah, I
great.
hope so. Yeah,
So do you have a timeline to build your own facility and manufacture this product locally?
yeah, we're looking at getting funds together in the next 12 months, and then it will probably be 2 to 3 years. So I'd hope by the end of 2024, start of 2025, we'd be at the point of making the first bats.
Very exciting. So if people wanted to learn more about life panels, how they're installed and how they perform, what's the best way to reach out to y'all?
The Instagram's good. We've got some helpful little reels on there, little bits and pieces, and then the website, we've got video guides, install guides.
You
But we
you have
are,
a pretty thorough data sheets on your website.
yeah,
Very
yeah. As you
technical.
know, I love the science, and so that's, like I said, I'm biased towards wood fiber because I'm biased towards the science first and foremost, and that speaks volumes. And I've tried to do that with the website, kind of break it down into just one-page documents,
Yeah.
so that it's overwhelming a lot of the information. But if it's available on a phone, it's just one page. You could read about air tightness just from the comfort of your phone while you're having a cup of tea or waiting for your Starbucks or whatever. And yeah, trying to make it accessible. I think that's the key phrase for me, that people can get in touch, use the website, happy to have chats, but make it accessible. It shouldn't be this ownership of information that only 1 or 2 people can have it,
That's
and
true, because
therefore
it's going
hold.
to help the entire industry.
Yeah,
It's going to
exactly.
help
Yeah,
homeowners and builders and
yeah,
everyone. So,
yeah,
why withhold something that, like you said, is an age-old technology that works in Europe? Why not spread the
yeah,
word in Australia too and worldwide?
yeah. That's
Yeah.
right. Yeah.
Well, thanks a lot, James, for sharing all that information with us. It was really great speaking with you. And I'm looking forward to seeing your manufacturing facility set up pretty soon.
Yeah. Thanks, Belinda, and thank you for all your skills and hard work. It's great.
Thank you.